Yeah, good morning, students. Good morning, students. So, in the previous classroom discussion topic, we had a discussion on a stack data structure, which is a linear data structure. Okay. So, now in today's classroom discussion topic, we would like to discuss about how do we implement multiple stacks in a array, a single array. Fine. So, multiple stacks implementation. So, now I would like to share my screen. Hope my screen is visible to you. Fine. So the this is a CDT 12 classroom discussion topic, week 4, lecture 3, multiple stacks. So summary of the previous CDT is that in the previous classroom discussion topic, we had a discussion on stacks. So stack, we have defined it as it is an ordered collection of homogeneous data elements, and where we are performing this insertion and deletions at one end only, that is called it as a top end of the stack. So insert operation is called it as a push operation, and delete operation is called it as a pop operation. And we are using these top variable, we would like to perform these operations on the stack. Fine. So now the objectives of this today's session is that array representation of multiple stacks, and then how these operations can be done on multiple stacks, push and pop operations, how we can do in multiple stacks. So the outcome of this today's session is that upon completion of this CDT, the students will be able to implement two stacks in a single array. So what do you mean by a multiple stacks? So generally it is nothing but more than one stack. If you implement, then it is called it as a multiple stacks. So in several applications, more than one stack may be required. Some stacks overflow quickly, whereas others are nearly empty. So we could not, we are more frequently one particular stack is used and other stack may not be used properly. Fine. So that is the reason. So we are going for an application which requires two stacks, for example x and y. So one can define an array A with n x elements, and another array B we can define with ny elements for implementation of the stack y. So now instead of defining two separate arrays, array A and array B with nx and ny elements, now we can define a single array st with the total number of elements n is equal to nx plus ny elements. Fine. So one stack will grow from the right end and other stack will grow from the left end. So this is called it as a multiple stack implementation in a single array. Suppose if we want to implement more than two stacks in a single array, how do we do that? So that can be done. One approach for implementation of multiple stacks, that is more than two stacks in a single array, is that we will divide that entire array whose size is equal to n. That total number of elements or total size of the array. For example, total size of the array is 10. Suppose we want to implement the three stacks. Suppose if you want to implement, so then what we will do, we will divide 10 by 3, which is approximately equal to 3 elements we are going to get. So in each stack, so stack 1, the first 3 elements we will take, and in stack 2, the next 3 elements we will take, and the next 4 elements we will take in stack what we can call it as stack 3. So like that, here we are dividing n is the total size of the array, and k is nothing but the number of stacks you want to implement. So we are dividing n by k, number of slots we are getting that. So we can use array of 0 to array of n by k minus 1 for first stack, and array of n by k to array of 2n by k minus 1 for second stack, and so on. So we can implement multiple stacks more than two within a single array. This is the approach we can use that. So to implement two stacks in one array, there are two methods here. So first is to divide that array into two equal parts, and then give one half to each stack. But this method is wastaging of the space will be there. So a better way is let the two stacks to push elements by comparing tops of each other and not up to one half of the array. Okay. So like this here we are taking here stack A. So and this is a stack B. Stack B is growing from this end. Stack A is growing from this end. Okay, from left hand stack A is growing, from right hand stack B is growing, and top A is the index variable which is pointing to the stack A, and top A is the another index variable which is pointing to this second stack B. So like this here we are implementing these two stacks within a single array. So when an array of stack n is used to represent two stacks, say stack A and stack B, then the value of n is such that the combined size of both the stack A and stack B will never exceed the total size of the array. So stack A will grow from left to right, whereas stack B will grow in opposite direction, that is right to left. Fine. So we will write a program to implement these two stacks within a single array, and we are defining this maximum size of the stack as 20. Size is 20. Then S is a stack. S is an array of size 20. So top A is initialized to -1, top B is initialized to size. So top B is decrementing and top A is incrementing, growing this. Okay, push A is a operation, push operation in stack A, push B is a push operation in stack B, pop A is the pop operation in stack A, pop B is the pop operation in B stack. So display A and display B, these are the operations which we are implementing that. And through a menu driven program, here we are writing the options we are taking from the user. First option push A, push B, second option push pop A, third option, like this we are creating a menu. Based on that menu, so we are taking the switch case statement to call these respective functions. Fine. So now push A. So push A is nothing but we are pushing the element into the stack A. If top A is equal to top B -1, then stack A is full. Else we are incrementing the top A plus plus, and then we are reading the element and we are inserting that element into the stack. Fine. So push B, this is nothing but if top A is equal to top B -1, the same condition is there to say that stack B is full. Else we will read that element and decrement the top B. Okay, top B minus minus, and then enter the element and insert that S of top B is equal to element. So this is what the push B operation. Okay, inserting an element into the stack B. Got the point? Fine. So this is a pop A, so which we are removing from the first stack A locally, we are removing that element. Top A is equal to -1, then stack A is empty, else delete element is equal to S of top A, then top A minus minus. So same operations similar to a stack, single stack which we have implemented using a one-dimensional array. So pop B, this is just exact reverse. If top B is greater than or equal to size, then stack B is empty. Else, what we are doing, we are deleting that S of top B location and then top B plus plus. We are incrementing the top pointer. Fine. So this is display A operation, displaying the stack A. So top A is equal to -1, stack A is empty. Else we are displaying int I is equal to 0, I less than or equal to top A, I plus plus, then display percentage D S of I. So similarly display B. So B stack we are displaying that if top B is greater than or equal to size, then stack B is empty. Else we have some elements in the stack B. So I is equal to size -1, I greater than or equal to top B, I minus minus. S of I we are printing that. So this is what the stack, two stacks we are implementing in a single one-dimensional array. Fine. So now this is a reflection spot here. So can you tell me what is the condition to check for multiple stacks implementation in a single array, whether that stack is full or not? That is what we did in the push operation, push A or push B operation. We have written a condition to check whether the stack which you have implemented in a single array is full or not. So if you are not able to answer this question, please watch this video from the beginning. Lecture outcomes are revisited here. After completion of this session, students will be able to implement multiple stacks in a single array. So summary of the session is that there are a lot of applications which may require that more than one stack is required here. Some stacks will go overflowing quickly. Some other stacks will always empty. So we need an application which requires two stacks. Then instead of defining two separate arrays for implementation of two stacks, we can implement in a single array such that one stack will grow from left to right direction and other stack will grow in from right to left direction. So this technique is called it as implementing multiple stacks in a single array. So if you want to implement more than two stacks in a single array, so the one approach is that the total size of the array will be divided into k number of slots based on how many number of stacks you are implementing that. So this is the approach what we are using here basically. Fine. So this is a lecture level practice problem. Write a program to implement two stacks in a single array. Just you can write this. And the further readings on this particular topic is that you can refer this particular textbook as well as the reference content. Okay. So thank you one and all.